Okay, so folks, we're finishing up the idea of function composition here before we can jump into the chain rule. So I just want to show you how we can think of we can be given one function here and we can think of it as its two pieces. So I want you to, given this function f of x, I want you to think of it as f of g of x. I'm missing out parentheses there. So for this, you have to identify the two parts, the inside piece and the outside piece, and you have to do it correctly so that when you compose the two pieces, the outer function would be the f of x. So in this case, let's jump to it. In this case, the outside function could be thought of as the cosine of x, and then that would make the inside function g of x the function x squared plus 1. So if you want, take the moment to find f of g of x, and notice that if you found f of g of x, that is, you took the cosine of x function, and everywhere you saw an x, you replaced it with g of x, you would indeed get our capital F of x here. So the order matters. I'm going to do this the wrong way first. Let's suppose we thought that the outside function was x plus 2 here, and then that the inside function was x to the 100th minus 5. Okay. Well, if you compose these in a certain way, you will get the right answer. But notice that in this case, f of g of x does not equal f, capital F, even though g of f of x equals capital F of x. So that goes back to the idea that order matters with function composition. So I'm out of room here, so I'm going to go ahead and clear this out, but maybe you've still got room. I'm going to go ahead and give the correct answer here. Then our outside function, and by the way, these are not unique answers, so this is not the only answer to this problem, but I'm going to think of the outside function as x to the 100th power minus 5, and then the inside function as x plus 2. And we see then if I input x plus 2 into x in the function for f of x, we do indeed get the capital F of x formula. So we're going to do a few more of these, and as I said, there are many viewpoints, and I want you to practice looking at this through a few different viewpoints. That will make you a little bit more fluent when we get to the chain rule. So one way, so this is just one way, we could think of this as being a composition of functions, is to say, let's call the outside function the cube root of x minus 3. Well, if that's the case, then that would make the inside function x minus 1 to the 5th. And notice if I input the inside function, g of x, in for x here, I will end up with the expression for capital F. So I want you to come up with another way of doing this, so that'll be for you to do. So now that we've reviewed function composition, we're ready to talk about how do you take derivatives of composition of functions. Okay, so there's not much to the statement of the chain rule. The chain rule says that suppose you've got some function that is a composition of two functions, and both of them are differentiable in their required places. Then the composition is also differentiable. This new function created from composing f and g is differentiable, and its derivative is given by this expression here. Its derivative is, and here's how I'll say it, it is the derivative of the outside function. The outside function was f of x. It's the derivative of the outside function, evaluated still at the inside function, and then we times that by, or we multiply that by the derivative of that innermost function. Okay. So let's put that into practice. We're going to take the derivative of this. I say first identify the f and g so that you can do the chain rule. I think that's really helpful. So we could think of f of x, the outer function, as the square root of x function. We know how to take its derivative. And we could think of g of x as the x squared plus 3x function. And I usually go with what I call the most natural choice for the inside-outside functions in that composition. So then when we go to find f prime of x, just following the rule above, I'm just recopying this rule above. Okay. So it says take the derivative of the outside function, evaluate it at the inner function. We know that the derivative of the square root function is 1 over 2 times the square root of x. But I'm going to evaluate it at g of x. So let's just we'll pause here, we'll put a g of x here, and then we'll multiply that by g prime of x. Okay, so that's what the chain rule says we can do. Take the derivative of the outer function, so the derivative of the square root would be 1 over 2 radical, evaluated at the inner function, times the derivative of that inner function. But we actually know what g of x is, and we know what its derivative is, so we could simplify this further. And by the way, I don't usually show this middle step. I don't usually do this middle step, but it's a nice pause for the first time. Anyway, we get 1 over, I'm going to run out of room here. We get 1 over 2. G of x was x squared plus 3x. So there's g of x. And then we multiply all of this by the derivative of g of x. Well, the derivative of g of x is 2x plus 3. And there we've taken the derivative using the chain rule. Okay?